To get started here, my name is Tony Gibbs. I'm a specialist solution architect here with Amazon Web Services. I'm not sure if we're going to do Q&A up here just because of the format of the silent disco thing. We'll do Q&A outside in the hall as long as you guys have questions. So we will go out there and do those. Steven from Yelp, he's a software engineer at Yelp. He's going to tell you guys a little bit about their story and how they operate at scale doing analytics on Amazon Redshift. And I have Himanshu, who's a product manager with Amazon Redshift, and he's going to go through and start out by telling you what's new with Amazon Redshift. Himanshu?
Thanks a lot, Tony. Hey, everyone. This is Himanshu Raja. I'm a senior product manager with Redshift. And with me, as Tony introduced, we have Stephen Moy, who's here to share the Yelp experience with Redshift. So let's get started. This session is all about what's new with Redshift, what we have been working on, and how will it address your data analytics need. But before we look at the new stuff, let's take a trip a little bit back in history. 7 years and 2 days ago, it was at this very event that Andy Jassy announced data warehousing as a managed service by Amazon. At that time, when Andy Jassy announced it, we thought how data warehousing would look like if AWS were to do it. And there were 4 key tenets that we established. The first one was it should be easy to provision and scale up massively. The second one was no licensing, pay-as-you-go business model. The third one was fast performance at the cheapest price, and then open and flexible with support for all your popular ETL and BI tools. When Redshift was launched and the years following it, we disrupted the market with our value proposition. $1,000 per terabyte per year was 10x cheaper than anything available on the market, and with the performance of 10x. We were the fastest growing service in AWS for a really long time until Amazon Aurora was launched in 2015. Just to reiterate here, again, 1/10 the cost of traditional data warehouse, automatic deployment and administration, and then compatible with popular BI tools. But since then, we have come a long way. Today, we are the largest cloud data warehouse in the world, and our customers have shown faith in our tenants that we established. We gain a lot by having such a big customer base. What we do is we learn from our customers. We learn from our variety of use cases. We learn from the variety of operational challenges they run into, and all our customers benefit from that. If you look at this slide, here is a bunch of logos, but the key here is you would see from healthcare to fast food service industries to financial sector, the breadth of customers is really amazing. At this reInvent alone, we had many customers presenting with us. You can watch these videos on YouTube as well. We had Fannie Mae, Comcast, Workday, Asurion, Nielsen, Warner Bros. Analytics, and today Yelp will be presenting with me. So let's talk about what do we see as trends in data warehousing. There are 3 key things that we see our customers are asking for. The first is, hey, help us to migrate from on-prem data warehouse to cloud as soon as possible with minimal amount of disruption. The second is the explosion in the type of data, the number of users querying that data, and the data sources. So the data warehouse as a hero of when it powered your analytics, right? With the traditional structured business data, we believe those days are gone. And what the requirement today is ability to join various data sources, clickstream, analytics, operational data with the reporting data in your data warehouse. And then the third big opportunity is bringing all of this together in a seamless manner by combining business data and event data to answer much more sophisticated end-to-end business questions is where the true value lies. How do we see Redshift solving that problem for the customer? So to realize the value of the data and take advantage from the benefits of embracing those trends that we just talk about, we are increasingly seeing customers moving to the data lake architecture. We see Redshift as a way for customers to move to that architecture. Most of the customers, when they migrate from on-prem data warehouse to Redshift, we would be the first service that they would migrate to. And then eventually, they would move to the data lake architecture if it makes sense for their business use case. And I'll be talking about a few of the features later on with which we are enabling this. So the approach that we see with Redshift is your lake house, which sits on top of your data lake and seamlessly integrate into it, giving you the ability to either query in open data formats in S3 or have all the data in Redshift to query it. Later on, I'll also be talking about a very exciting announcement from us, RA3 with managed storage, where all the data sits in the Redshift managed storage, and you have the ability to combine it with the open data format in S3. So you get best of the both worlds. You can have the data in managed storage, let Redshift manage it completely for you, or you can put the data in the open data format using Redshift as a transformation engine and dump it in S3 to be consumed by other services such as Amazon SageMaker. So let me talk about what the tenants look like. What are the things that we focus today? We are still true to some of our original tenants, best performance at the lowest cost, most secure and compliant. Either you run a 25-cent single node or you run a 128 node cluster. Irrespective, you get the same level of security and certification built in. It all comes as a product in the product itself. But then the things that we are really focused on right now is the data lake and AWS integration, the scalability, and for today's session as well, especially I will be focused on the fully managed aspect of it. So all of this growth in the business has resulted in tremendous amount of delivery from our team as well. In the last 18 months alone, we have delivered 200 plus features, and our goal is to only increase the speed of delivery. So we are innovating very, very rapidly, and the way we innovate is by hearing from you, hearing from our customers, what are you telling us, and innovating on behalf of our customers. So in terms of what we will be talking about today, I'll be covering three main themes of features that we have released and focused on. The first theme will be performance and scalability. The second theme will be data lake and AWS integration. And then the third part will be fully managed. There are a lot of features on this list, and I will be picking and choosing and talking about some of those features specifically. So let's start with some big announcements. The first one is RA3 with Redshift managed storage. So let's take a step back and start with the problem statement. So the challenge that we heard from our customers was that, hey, Redshift is really fast. I love the performance. I love that it's available at the really, really cheap price. But as my data is growing, I need to keep adding nodes. So the exponential growth in data was causing management, performance, and scaling challenges. And then what was happening was that customers had to decide what data they need to put in their data warehouse. The other way to look at this is also that the compute and storage needs are varying independently as the organizations are going. So let's talk about the compute scaling first. So what the two big challenges we see in the compute, the need to scale compute is to handle increased query load during peak times, and then to ingest data fast and make it available for querying in near real time. That's the need for scaling the compute. The second part of scaling is the storage scaling. We see the need for customers to query, to store more and more data in the data warehouse, and then just to have the data warehouse query it seamlessly. We also heard from our customers that they want to pay separately for storage and compute, and they want to scale it independently and not be tied to each other. So I'm super happy to announce that we just GA'd on Tuesday during Andy Jassy's keynote, our third generation of Redshift compute instance, RA3. RA3 is generally available in 11 AWS regions from US, Europe, and Asia Pacific, and we will be launching in other regions soon as well. The key part of RA3 is built on 3 fundamental pieces of architecture. The first part is the managed storage. The second part is the high-speed cache in the compute nodes. And then the third part is the high bandwidth networking, connecting the high-speed cache to the managed storage. What that allows, the high networking bandwidth, allows us to move data at really, really fast speeds in order to minimize the effect of not having data sitting next to the compute. The managed storage allows us to actually mark the blocks. So what Redshift does is we developed a really smart algorithm to look at your query patterns, and then based on that, we mark the blocks on the degree of hotness, on how they are being accessed. And then the system is smart enough to cache those blocks that we know that are very frequently accessed in the local cache. If there is a block miss, we basically bring it from the managed storage really, really fast, thanks to the high networking bandwidth. So the advantages that you get is you only need to scale the data warehouse based on your compute needs. You don't need to worry about how much data you have. You pay separately for compute and storage, and we're going to be talking about the prices in the next slide. And then the migration is super easy. All it takes is to take a snapshot. If you have an existing Redshift cluster, you take a snapshot and you do a restore, and you are good to go. So there are no changes to workflow required. Let's dive a little bit deep on the pricing and the positioning of it. So we did quite an extensive beta. Some people sitting in the room were actually invited to the beta as well. And what we saw from our customers and from our internal test is compared to our existing DS2 instance type, you get 2x the performance, up to 2x the performance, and 2x the storage space at the same on-demand price. You get 3x performance compared to any other cloud data warehouse. And the minimum size, so you start with a 2-node cluster with a starting quota of 128 terabytes in the managed storage. And you can scale that all the way up to 8 petabytes with 128 nodes. So the pricing is on-demand pricing is at $13.04 per node per hour. The storage, you pay 2.4 cents per GB month, which is just a 0.1 cent more what you pay for S3, and then you can scale to tens of petabytes of data. The bigger node is generally available as of Tuesday. The smaller node, we are planning to announce it in Q1 next year. This was some of the customer, we got a really good feedback on this feature. This was some of the customer feedback that we got. There's a lot of text here, but the key insight here is customers were not only able to get great performance, but increased in storage space thanks to the managed storage, but also no change in cost. So that was really good, very good feedback from our customers. Now let's talk about the second feature on our list, which is in preview starting Tuesday. You can go and sign up for AQUA preview. So let me talk about a little bit what AQUA is. AQUA stands for Advanced Query Accelerator for Amazon Redshift. It's a new distributed and hardware accelerated processing layer. The whole idea of AQUA is to bring compute to the storage layer itself, rather than bringing data to the compute. The key part of the architecture of AQUA has 3 key pieces. Let me go by one. The first key piece is bring compute closer to the storage. So pushing down of scans and aggregation happen in the AQUA layer itself. So we minimize the amount of data that is transferred between the storage layer to the compute layer. That's one. The second key part of the innovation here is the AWS design processors. So AQUA uses AWS design processors to accelerate queries. These are AWS Nitro chips adopted to speed up data encryption and compression and custom analytics processor. It's all implemented in FPGAs, so we are very excited about that piece of technology to accelerate operations as filtering and aggregation. again, the key is we make filter and aggregation and scans really, really fast, and then only send the data that is needed by the query up to the compute nodes for further processing. The third key part is this is all managed by Redshift. It's completely seamless to you. So what we can take advantage of our scale, and then we can give out the scale out architecture approach to customers. So you basically get the right amount of AQUA capacity that is needed by your queries, all seamless to you. So it's in preview starting Tuesday, since Tuesday, and you can sign up for the preview for AQUA. Now let me shift gears to talk a little bit about out-of-box performance in Redshift and what we have been doing. So the key for us has been we want to give a really, really great performance with Redshift to our customers without any tuning. No distribution keys, no sort keys, nothing. Just straight up, you load data in Redshift and start querying. So we have been working very hard at it, and I'm very happy to announce that Redshift now runs out of box 2x faster than it was just in June 19. So on the blue bar that you see is June 19. And then since June 19, November 19, we did the benchmarking again, and you can see we have 2.35x speed up in queries. Out of box, no disk keys, sort keys needed. How did we do that? Couple of key innovations. The first one is AZ64, and I'm going to talk a little bit more about it in the next slide. But AZ64 is a proprietary compression algorithm that we developed that not only speeds up queries, but also give better compression. The second key aspect of the out-of-box performance was improvement in Bloom filters for basically co-located and broadcasted join queries. The third key aspect was we just made improvements to the query planner to take advantage of better networking, better CPU, especially with RA3. And then the hyperlog log statistics we also implemented in Redshift to speed up queries, and then cache optimized aggregation and join processing. So all of these small changes, they got added up, and now we run 2x faster than we did just a few months ago. So let me deep dive specifically into AZ64. AZ64, as I said, is a compression encoding that not only gives you better performance, faster performance, but also give you better compression ratio. It leverages SIMD instructions for parallel processing, and it's applicable for all numeric and data types. On the right side, you can see that this is from our testing that for you get better compression and you get better performance. So we are super excited about this and looking forward to get feedback from you on AZ64. Now let me talk about the fourth key feature in our performance and scalability. Materialized views was also announced on Tuesday by Andy Jassy, and it's available for public preview since then. It's super simple. All you need to do is to create a cluster, and when you are creating a cluster, you will have an option to choose a track, and you can choose a preview track, and you get materialized view as part of that build. So let's talk a little bit about materialized views. The key advantage here is compute once, query many times. The speed up in our test, what we saw was 2x to 10x speed up, especially for dashboarding queries. The key part of the materialized views is that you are able to join tables, you are able to filter, aggregate, and projections. On the right side, I have an example where you have two tables. You have the store, owner, location. Then you have item, store, the customer, and the price. And you just want to find out what were the total sales by location. And then what Materialized View is doing is creating that aggregation for you here and materializing it for fast performance. Apart from performance, there is also a few other benefits. The second benefit is you simplify and accelerate ETL and BI pipelines. The key part with the way we implemented materialized views, it gives you the ability to have incremental refresh. That means we are not recomputing the complete materialized view every time, but just incrementally refresh it based on the data that has changed. It's user-triggered maintenance, so you get to decide when you want to trigger the refresh of the materialized view. And it also helps in the easier and faster migration. So moving on, the next, when we talk about scalability, for us, performance is important, but also looking at the new use cases and how we are scaling the use of Redshift within organization. So I'm very happy to announce that Redshift now supports the ability to ingest and query spatial data. We introduced a new data type in Redshift called geometry. It ingests, store, and analyze spatial data. What can spatial data do? We support shapes such as point, line string, polygon, and geometry collection. We also support multi-point, multi-line string, multi-polygon, geometry, and the geometry collection. We also have support for 40+ SQL spatial functions to construct geometric shapes, import, export, access, and process the spatial data. In the next slide, I'm going to look at a specific example of what you see a heat map here. And we're going to deep dive a little bit of what you can actually do with this spatial data type, geometry. So what you see here is a map of Berlin. Our spatial data team is based in Berlin. So they took out the map of Berlin, and they projected the Airbnb locations in Berlin. So what you see is 23,000 Airbnb locations and accommodations in Berlin, and the 150 zip codes with metadata such as name and price. The map shows all accommodations. Each point is an accommodation in the current bounding box defined by the polygon. So you see the polygon, and then these are the coordinates. So there are functions such as geom from text that creates the geometry object within the given polygon coordinate. Or there are functions such as st-within that checks whether a given point or a shape falls within a given polygon or geometry object. You have many, many functions as well to take advantage of. So you have geometry functions, you have spatial accessors, you have predicates, you have things like st distance with which you can calculate distance between 2 points. And then we support the spatial formats. So super excited to see what you folks do with the geometry data type. So then let me talk about the last key item in performance and scalability, concurrency scaling. So we announced concurrency scaling in March. We GA'd concurrency scaling in March last year, and we have had very good feedback from customers. Concurrency scaling is free for 97% of the customers, thanks to the 1 hour credit every day, which accumulates over a month. But what we have been continue to make improvements to concurrency scaling, and we have improved the throughput of concurrency scaling by 35x in 2019. So super happy about and super proud of the work team did here. The key here to notice is that our throughput scales linearly. So every single extra dollar that you spend, you get the linear increase in throughput as you add more concurrency scaling clusters. And in the test that you see, a 3 terabyte data set was 220 concurrent queries were running with a throughput of 14,000, more than 12,000 queries. Let me walk quickly through here. The second theme is the data lake and AWS integration. And very excited to announce that with Redshift now you can query RDS or Postgres Aurora database as an external table. The benefit here is you can move data from your Aurora or RDS from Postgres or RDS table without any ETL. You can create tables where you are getting the live data from Aurora, and then you are able to combine it with your analytics data in Redshift and with a single view. So here is an example. I'll not go into the detail, but the example that you see here is we are creating a view with data sets in S3, in Redshift, and then in Aurora Postgres APG database. And then on the right side, a query, a simple query that how your analyst will query Redshift, the same exact way. He's querying the view, and you are able to find out from the very hot data in Aurora dataset, combine it with very cold data in S3, and then the data in Redshift. All of that is done seamlessly. It's also available for preview, and it's available along with Materialized view. So it's the same build that you will, if you move your cluster to the preview track, you get that as part of both Materialized views and the federated query. I'll take questions later. So I just need to go through this. The next feature I would love to talk about is the data lake export in Parquet. So with Redshift, helping you to move to the data lake architecture. So you can just simply export data in Parquet format in S3. In fact, what is really cool about this part is you not only just you can unload data, but then you can also copy data from S3, right? So what you can do actually, you can use Spectrum. You can use Spectrum to query the data in S3. You can actually convert it, transform it howsoever you want it, and then unload it to S3. Potentially, you can do all of that in a single query. So Redshift gives you the ability to act as your ETL engine, should you want to do so. Then let me switch gears and talk about the self-optimizing, easy to maintain, fully managed area that we have been focused on. 3 key pieces here. Redshift is fully managed. Out-of-box performance is now 2x faster, more than 2x faster. So the goal is when you start with Redshift, there is nothing required to do from your side. But then what we have noticed is as number of customers increased, as the number of users querying the database increase, the data sets size increase, what we see is that there are opportunities to optimize the database to get the best out of the hardware, to get the maximum throughput out of the hardware. Versus you can scale, you can add more hardware, but then of course it increases your spend, and we think there is a better way to do it. The better way is to run automatic optimization on your behalf. And then we still want to be easy to optimize. You know your use case best, and in cases for specific business needs, if you need to tune, if you need to specify a particular setting, you still have that option to do it. So let me quickly move to few key items in self-managed, easy to use. The first is we have completely automated the maintenance tasks that were required earlier in Redshift. We have introduced a concept of workers where the Redshift now runs these jobs on your behalf when there is not many queries running on your side. So the system is smart enough to go and do these maintenance tasks on your behalf. And the moment we see that there is a query coming, we go and pause this work, and then the worker just goes back to sleep. So today, Analyze is automated. The table distribution style between all and even is automated. And then the vacuum delete is also automated as well. For distribution keys and sort keys, we are giving recommendations based on your usage patterns via Redshift Advisor. It gives a block of SQL that you just need to execute in order to apply the right distribution keys and sort keys to get the maximum performance. I'm going to take just a minute to talk about auto table sort because it's a pretty cool feature and it solves a big problem that we have heard from our customers. Up until now, running vacuum in Redshift, especially the vacuum sort, is an expensive operation, takes a lot of compute and a lot of memory, just because sorting itself, by definition, is an expensive process. What auto table sort does is it divides the table into partitions, hot and cold partitions, and then goes and sorts the hot partitions first. So it really reduces the amount of compute that is needed, but also reduces the cost of doing vacuum. So much so that ATS is running in the background, and the end user queries do not even notice that ATS is running in the background. So super excited about ATS. Customers don't need to worry about running maintenance tasks such as vacuum and analyze. I'm going to run through quickly. I need to make sure Steven has time. We also refreshed our complete management console on Redshift. The two key pieces here. The first is our goal was to give you a command center-like dashboard to figure out if something is going unexpected, to figure out and help you do the RCA in shortest time possible. The other part is the query editor. Now you can share the query editor with your analyst without sharing the complete console. You have a web endpoint. You can share the query editor. They log in using IAM credentials, and then they can just query Redshift cluster directly without having access to the console. Let me just spend last minute on AutoWLM with query priorities. So AutoWLM with query priorities is a very, very powerful feature in Redshift with which you get to use your resources where you want them. AutoWLM makes it super easy to maximize the query throughput and get consistent performance. There are two key pieces of AutoWLM. The first is dynamic concurrency, where we manage the concurrency for you. That is how many queries to process in parallel based on the workload. The second key piece of AutoWLM is query priorities, where you can define priorities based on your business importance. So if you say that, hey, ETL is high priority and BI is normal priority, we will make sure that the ETL gets right of the way. System is smart enough to make sure queries, low priority queries, are not penalized forever or get stuck. So we will make sure that every query does get resources eventually, but we prioritize the queries for you. This is a very powerful feature with concurrency scaling, because now you get to decide where you want to spend your money. If you say that ETL is high priority, but at the same time when you are running your ETL, you want to give consistent SLAs to your BI or reporting queue, you can just switch on concurrency scaling on the reporting queue only. And that way, ETL is getting executed in the main cluster, and then the reporting queries can go to the concurrency scale clusters. The last feature I would just quickly like to talk about is this is the second last, Elastic Resize Scheduler. With this, now you can size up and size down. During the weekends, for example, you can size down to save cost and then size up during the weekdays. And then the last thing I would like to talk about is stored procedures. We introduced stored procedures earlier this year. Redshift supports PL, PG SQL-based support procedures. The whole idea is to help migrations faster, give you the flexibility to run code where the data is to efficiently run ETL, data validation, custom business logic. So we are seeing very good adoption of stored procedures. Customers are using them in very creative ways. So super excited to see how customers keep on using stored procedures. So with that, again, just reiterating 3 key themes we were focused on in this talk: performance and scalability, data lake and AWS integration, and then the fully managed aspect of Redshift. So thanks a lot. With that, I would like to bring Steven to share his experience on how Yelp is building analytics at scale with Amazon Redshift.
Thank you, Himanshu. Hi, my name is Steven. I am a software engineer in a team called Metrics Data at Yelp. So our team is responsible for a data product called a clickstream sessionization. On top of that, we also manage the data warehouse and also the data lake for our company. Now, the intent is for our team to be able to provide SQL on anything for all our users. So agenda today, I'll cover who are the Yelp Analytics audience. I'll give you a little bit background of how we structure our Yelp data ecosystem. And also, being a Redshift session, it's no secret, Redshift is at the heart of our analytics stack. So I will tell you why we arrived at using Redshift. And I will conclude with what we're planning in the upcoming year to advance the next stage of our ecosystem. So who's our audience? Yelp's core mission is to connecting people with great local businesses. Now, these numbers are from Q3. We already have 4.8 million claimed local business locations, and we have 38 million app unique devices every month. I want to call attention to the scale that Yelp is operating in. Now, if you're not familiar with Yelp, you can make a reservation at your favorite restaurants. And since it's just after Thanksgiving, if you ever have the unfortunate incidents of clogged drain pipes, you can hire a professional using Yelp to help you with your plumbing problems. And of course, to prepare for reInvent, you can book your favorite stylist on Yelp. One of the pillars of Yelp's ecosystem is our local business owners. And Yelp provides free tools for those local business owners to claim their business page such that they can track how many users are viewing their business page and what are potential customer leads landing on their business. Now, earlier, recall we have 4.8 million claimed local business pages and 38 million app uniques. Now, naively, if you ever need to create all the statistics for our business owners, this is over 100 trillion calculations. Now, of course, in computer science, we've learned a lot of techniques to prune data, but still, this is a two-pronged problem. You need compute at scale, and AWS has always leads in the diversity of compute instances at the right size of your computation. Now, of course, we have to remember storage at scale. At Yelp, we have embraced the object store S3 for a very long time now. We have now accumulated over 25 petabytes of data on S3. And at storage at scale, what we really love about S3 is the diversity of options to help us drive our costs lower. Currently, the Yelp's data lake is mostly on the intelligent tiering. This is a feature that was being announced at reInvent last year, and Yelp has quickly adopted. For our business data on the data lake, we're using the intelligent tiering. The reason is, without us writing any extra code, the machine learning on S3 will actually bring out data in between infrequent access versus the normal S3 tier, all based on our observing the usage pattern, which means they get us the best cost, and we continue to do our business logic at what we're good at. Now, our analytics audience doesn't just stop at our external customers. We find the entire organization really want all the data at their fingertips in order to help them to do business decision. Our analysts and data scientists wanted to know what are the variables between the various aspects of our business. The product manager needs to be able to make their feature decision by looking at our experimental results. And of course, our engineers continue to use the data pipeline to build all the assets and all the features on the site, and also to build much more machine learning models. What that means is our data ecosystem must be able to provide all the services to the entire company. And I'll give you a little bit of background on that. Now, before that, I wanted you to think about this quote. One size fits all, an idea whose time has come and gone. The quote comes from Michael Stonebraker, an ACM Turing Award winner. If you're not familiar with ACM Turing Award, it is akin to the Nobel Prize in the field of computer science. Stonebraker and his co-authors on this paper have looked at sort of traditionally how database, the architecture of RDBMS, is no longer sufficing to do all the explosive data volume and the unique data model that is coming in the database ecosystem. And taking from that nugget of wisdom, when we build out our data ecosystem, we make sure that we pick the right tool for the right job. Now, on the left side, we have very low latency data systems. We have MySQL, Cassandra. They power a lot of our online use cases at Yelp. And of course, with Elasticsearch, that help us to power all the Yelp searches with very low latency. Now, those systems is not going to be able to give us a lot of aggregate bandwidth, meaning that if one of our developers try to do table scan on MySQL, our DRE team that manage the MySQL clusters will not be very happy with them. Now, there's other systems that are really good at those table scans, such as Amazon Redshift. And also, when we need a lot of aggregate bandwidth to collect all the pictures that users are uploading on Yelp, we have Amazon S3. Those systems give us really large aggregate bandwidth, but they don't tend to have the same latency characteristics as the other system I mentioned earlier. But you may wonder, great, you use the right tool for the right job, but what about data silos? A really bad idea would be to develop point-to-point batches to move data in between those systems. Every time we want to take advantage of a new system, we're going to have to every time if we want to introduce a new data system, they're going to have to develop all these point-to-point batches before they can move the data to do their business logic. And this is sort of our first generation of how we approach the system almost 7 years ago. Now, in the past 2.5 years, we have moved to a much different paradigm. And we call it the data connector ecosystems. And at the heart is Apache Kafka. Apache Kafka is a really good message bus for us to connect all these different events. On the left side, we call them those data sources. And we use this change data capture technology to bring all those changes into Kafka. And we process all that events on Kafka using Apache Flink. That gives us real-time streaming capability. And then depends on the data sinks on the right side, we can craft the right connector and take advantage of those I/O aspect of those other systems. What's really nice after we've launched a system, it has been in place for 2 years, any feature team that needs to move data from one to another no longer needs to know about all the I/O characteristics of those data systems. All they need to do is to run a command line to say, I want to add a connection for my table in MySQL, and then I want to bring it to Redshift. That's as easy as that. Now, I want to show you what I meant when I say Redshift as the heart of our data stack. On the left side, bottom left, if you recognize the Redshift logo, that is majority where most of our data is being stored inside Amazon Redshift. I call it the data tier. Now, a lot of the time, for majority of our organization, they want to visualize and summarize, aggregate the data. They can, since Redshift is a SQL-capable tool, they can use tools like Tableau or QuickSight or a Jupyter Notebook directly crafting SQL queries, and they can get the data they needed. What about the engineers? The engineers want options. Sometimes they wanted to build other systems where they want to build machine learning model. They like the Spark big data frameworks. What we have done is to connect Redshift and bring those data out into the data lake. And with that, we connect it with the Glue catalog. Then our engineering team can use systems such as EMR and SageMaker to build machine learning models. Now, one unique characteristics is that once we bring the data out into the data lake, it also opens up some options such as Athena, where all the different tools in the AWS ecosystems are oftentimes very well connected together that give us flexibility on exploring new ways to use our data. So, Redshift. How do we end up using Redshift? There are many other competing systems, but we have found Redshift serves a really good needs of our organization. So back in 2014, we were still, like many of our peers, using Hadoop on EMR, but we were looking to refresh our architecture. In 2014, when we go out into the marketplace and trying to pick the next generation system, we know these are the tenants of the next system. And one thing we want to make sure is that SIMD support. As you know, processors these days don't get any faster anymore. Instead, they keep adding more long register instructions. But unless your system is taking advantage of that extra hardware just sitting there, you're basically not utilize the full potentials of your hardware. Now, of course, Redshift being a really capable system fits all those characteristics. These are the number of queries that have been running in our system for the last 2 years. Each bar is 3 months worth of the count of the query count hitting one of our flagship data warehouse. You know there's a consistent growth of queries, except why the drop there? And this is a cautionary tale that I want to share with you. At some point, as we are monitoring the query pattern of our data warehouse, we notice a really interesting pattern emerging, and that is an OLTP pattern. Now you have to be careful. Remember, Redshift is a data warehouse for an OLAP access pattern. When you want to do a lot of point lookups, you are really under-leveraging all the I/O bandwidth of your system. In fact, one of our team was tying point lookups into Redshift. Cluster didn't fall down, but of course, it is a waste of just back and forth latency. So once we helped the team to restructure their data flow, we were able to drop the query count again. Now, Redshift team continues to figure ways to surprise us. We didn't know ahead of time, but then when they announced Redshift Spectrum, it really have changed the game. So what Redshift Spectrum gives us is that increased flexibility to tap to our data on the data lake. And what that means is that for infrequently accessed data, such as clickstream, we can now move those infrequently accessed data into the data lake. S3 is a really cost-effective way to store that kind of data. And in aggregate, it's also able to help us to push our costs down. So we have been using Redshift Spectrum a little bit over 9 months now. Each of those vertical bar is a month of usage. On the y-axis is the number of bytes being transferred in between the data lake and Redshift. We're talking about petabytes of data now. Yelp do have a very high volume of clickstream data. And imagine if we need to store all this clickstream data on Redshift, I'm going to have a lot of conversation with our CFO. But Redshift Spectrum have really helped in this regard to give us that choices when we have a lot of infrequently accessed data. Then there's concurrency scaling. We have used Redshift since 2014, and if some of you are also started that era, you will remember concurrencies is something that you have to gingerly manipulate around with Redshift. When concurrency scaling was delivered, we have quickly turned it on. If you have not turned it on yet, I ask you to turn it on, because for 97% of Redshift customers, you get a free hour of every 24 hours of your cluster operation. It turns out we are at that 3%, so we do pay a little bit, but actually we still have find a lot of usage for the concurrency scaling. So what is this graph? This is a 30-day visualization. So on the y-axis is the average of extra concurrency scale cluster that was being launched. And we don't have to take any administrative work when we use concurrency scaling. Redshift automatically observe your queue wait time and then spin those concurrency cluster up and surface the low. And it's very dynamic. What we really like about it is our team no longer has to go being pinged by our internal users to say, hey, your cluster is slow, please scale it up. Now we just let concurrency scale take care of it, and we can go back and focus on other types of work. Now, there's another thing. Earlier, if you kind of remember sort of the query frequency that we have, there are hundreds of thousands, millions of queries. And oftentimes, when you have to deal with concurrency, in Redshift, in the old classic way, is you can do manual WLM. What that means is that by default, Redshift can run 5 concurrent queries, but let's say you want to be able to support more, and you can, toggle those numbers and give more concurrency at the expense of the queries finishing slower. Now, we have a cluster, and we have very diverse query requirement. We have very short aggregate queries. We have exploratory queries. When users come to us and say, hi, I have a query, it's running kind of slow, can you help us with it? Yes, there's an explain plan, and if you ever have to support a large amount of users coming to you and help them with explain plan, it's tough. So it's nice that machine learning comes to the rescue with AutoWLM. So AutoWLM will actually analyze the explain plan of the queries being run and then figure out what is the appropriate amount of resources that needs to be used. Before AutoWLM, there is this capability that you can use this to declare the session how many slots to use. But it's a really leaky abstraction. Once you're exposing to the number of slots to our users, sometimes they get greedy and always use all the slots, and you won't have a good time. So with turn on AutoWLM, it has saved us a lot of that type of DBA work. What's even better is AutoWLM with query priority. For a long time, we have a very complicated queue setup because we need to support both ETL, and then we have reports and all our data scientists exploratory queries. Now with query priority, what we have used it with is to make sure that our ETL always get high priority into providing fresh data into the warehouse. And we left most of the reporting as long as the query finish in 10 minutes in the normal priority. So people, as long as their query is finished within 10 minutes, we try not to interrupt them too much. Now, the really killer one is when people's queries are running more than 30 minutes, which are the tougher ones to swallow because you don't want them to overwhelm your cluster, but you also don't want to kill them because they're doing useful work. So we have bin it into lower priority once a query have exceed 30 minutes of runtime. We were really excited. We helped beta testing the RA3 new instance. We really consider that as the next generation of data warehousing. So this graph is a comparison of one of our DS2 cluster. So our DS2 cluster setup is 9 nodes, and we'll use the recommendation to basically just half the number of nodes when we spin RA3 up. What we observe is a consistent performance increase. And also remember, you get a lot more managed storage and close to 2x better performance. Those QA, Q9s are different query pattern. One thing as we were going through that beta testing is we have now adopted an approach where we are putting together our own workload benchmark because, as you know, yes, there are the TBCDS, but in reality, does it really reflect the characteristics of your organization's workload? These are actual queries being run on our cluster, and that's how we assemble this workload. And we can have high confidence when we convert our DS2 cluster to RA3. One thing I want to know is what about those DC2 SSD cluster? We have some of those as well. For those, you want to be careful of how many nodes when you're doing the conversion to RA3. The RA3 is a very unique characteristics of I/O and CPUs. So we noticed that for some of our DC2 workload, we can actually get better performance with RA3, but some may not be as good. So I encourage you to really proceed with caution when you are looking at how to convert your DC2 cluster into RA3. Pay attention to your workload pattern. So looking forward. Now, I want to give a plug to something we've been working on in the Redshift community front. So at Yelp, like many other organizations, we are really heavy on machine learning now. And if you talk to any machine learning engineers, they will say data is the field of any machine learning algorithms. So what we want to make sure is there is a very seamless connection between your Redshift cluster and our Spark cluster. At Yelp, we're mostly using Spark to do our machine learning workload right now. That is a GitHub link to a Spark Redshift connector. Spark Redshift connector originally was started by the fine folks at Databricks, and as they are advancing their work, there are less activity in the original GitHub repo. What we have wanted to do is to ensure that there's a vibrant community between Redshift and Spark. So we have lead the work to revamp the connector to make it Spark 2.4 compatible. So now you can find the necessary jars to bring it down into a Spark cluster, and you can be able to access all your Redshift data using the Spark data frame. And really mean it to be community driven. So take a look. If you find it useful, we welcome any pull requests. We're also looking for committer as well. So come talk to me if you want to do some work over there. So what is in 2020 is we're really a huge believer on self-driving data systems. What do I mean by self-driving data system? What we notice is the amount of table growth in our Redshift cluster is only picking up a pace. With the data ecosystem, the connector ecosystem that I mentioned, it's now completely seamless for our teams to add more data into Redshift. But data evolves, and what happens is when they evolve, we want to make sure that there's proper life cycles being brought to those tables that are no longer necessary. But we cannot manage all the tables for all our teams, and some of the teams with the connector ecosystem do not necessarily have that expertise in the Redshift infrastructure. So we want it to be self-managed, and we are looking into how to put the sensors in place and the right actuators and the necessary intelligence to roll back if we make the wrong decisions. And one thing is a really hot topic these days is data provenance. Data provenance is very important when you have a highly connected data graph. You want to make sure that you know what is the SLO for all your data, kind of what team is responsible for, and how to get help when you needed it. This is a huge investment in our organization to be able to seamlessly to bring in all the data provenance as well. And got a plug here, we are hiring at Yelp, so if any of the work that I mentioned is interesting, please talk to us and check out our website. Thank you.